course, we can't forget the mighty drones, right? They really are. I don't think they get enough attention, and I'm really excited to see some of the newer research coming out, and really what more we can learn about drones. But in essence, they are replicas, at least, of the genetic information from their moms. And so if you really have a queen you like, that's, rearing daughters off of her is only going to give you 50% of her information. This topic is one of really keen interest of mine. I want to say I'm super fascinated, and it really ties in well with what Dr. Martin and also Dr. Peck. And I just want to thank them both because they validate my insanity for this, meaning that we aren't insane, that we all are similarly, on these pages within the same chapter and trying to figure out this larger puzzle piece of our bees, where they live, what does it mean for us as their stewards, what's this whole relationship about? And so that's what this talk is gonna really focus on. So as mentioned, and you'll see some echoes throughout my presentation for Dr. Peck as well. So I'm glad that we like some of the similar research. But I will be talking more about epigenetics, or how this environment genotype interaction. And it's not so much that the genes are being changed, but the way in which they're reacting is plastic. It's what we call genetic plasticity, and that's a part of this epigenetics. I don't know if I need to see the raised hand or if that's somebody else. You're going to check that probably, right? Okay. Let me see if I can go forward. All right. So one of the things I kind of wanted to share, and I love a lot of visuals because while I can understand graphs and appreciate them, and text, of course, is helpful, I like for people to imagine and kind of see how things tie into each other. And so a lot of what's happening around every organism, and especially our bees, is in flux, right? It's constantly moving. And a lot of this is basically information. A lot of it's encoded in not only in the genes themselves, but it's also carried through the air. I mean, we've got wind, we've got weather, we've got solar radiation, we've got radio waves, we've got electromagnetic, I mean, all these things that are happening. And it's a major sort of interface that we are all living in. It's very dynamic. But within that interface of constantly moving, we're trying to find not only who we are as people, but how we live in this world. And so the same is for our bees. They've got all this information flying around them, and they themselves are looking for where to make it work, right? And not only that, but how to learn from where they're at in order to pass that information on. And so this sort of quest for good food, and I kind of shared this as sort of, because it's fun, I thought it looked cute, but it's, it's this frequency that's happening, this larger choreography between plants and pollinators. But not only that, it's actually happening in the real world too. And so this is actually some video I took a couple of years ago when I was in Spain. And that's actually the Sierra Nevadas in the background. That's on the flip side of Granada. And actually these are almond orchards right here that are just starting to pop. So I think it's really beautiful to kind of see that there's snow up there, but there are these nut orchards right down below in the valley. And the road that you get to for this actually runs all the way down into Almeria, where they filmed The Good, the Bad, and the Ugly, into Bareness, which is pretty cool. In case anybody likes that. I've come from the Southwest, so I like those movies. I love Westerns. But that whole interface and what the bees are finding and learning from, right? They're actually bringing that information home. And they're bringing it in the form of a dance, right? Because now they're going to dance and communicate with each other where to find this stuff. Or they're going to be communicating with each other through pheromone cues and figuring out, where to build a comb, in what direction. And all of this, apart from this picture, is normally happening in the dark, which is pretty amazing that you can get, tens of thousands of seamstresses all building this magnificent architecture in the dark. But these stories are something that it becomes learned behavior over time. And it can actually be passed on, but we'll talk a little bit about that, especially as it relates to what Dr. Peck shared, which I love the cats. I thought that was so great. I really appreciated that. Um, but these types of memories are these stories, right? And I'm about to take you all on a little storytelling journey here. I hope you will be as smiling and happy as these kids are in this little video, as we sort of meander through what I call the micro and macro sort of universes of beekeeping and bee breeding. And I constantly bounce back and forth in that sort of, I want to say it's almost like limbo, but purgatory, but it's also like the void, but it's not stagnant. There's a lot of stuff going on because you recognize that you are but one small piece of this larger puzzle, but what you do connects to this larger, basically existence. So for me, me and my partner, sorry, Mark Spitzig, who I mentioned is a Michigander, we keep bees in the Southern Rockies. And so for us right now, our main interface or sort of stage is at high elevation, which, believe it or not, is really close to the timing of northern Michigan as well. And that really surprised Mark, actually, because when I first convinced him to come to New Mexico, he thought all his bees would turn Africanized, for one. That didn't happen. For two, he thought it was going to be warm all year round. There'd be, he could basically rear queens for longer, but due to the elevation, it's actually a really short growing season. So we're at about 8,300 feet, which is about 2,500 meters of elevation. So this is obviously a summer shot. Actually, I think this might be late summer because grass is starting to turn and there's no snow on the peaks. But usually we'll have snow on the peaks from September through June, July. So there's usually at least some smidgen still left up there. But solar radiation is intense, so we still can get pretty warm, but the nights can stay pretty cool. They drop down to about 50 even during the summer. That is one experience, right? And then we've had this other experience too, where we go out to California, and I'll talk a little bit about that and some of the other places that we've worked in, but how that has played into not only our selection process, but to, the observations that you see and that you experience, and how that also translates to beekeepers working together. And of course, all of these sort of experiences are happening not just in one location or multiple locations, but they're happening through different seasons, right? And us figuring out what's happening when and what that all means. I mean, for me, this is the most thrilling part of beekeeping because it is so dynamic. There's never a dull moment. And I get to that point usually in October where I'm so ready to just be like, okay, bees are ready, they're done, like they're gonna overwinter. And I'm exhausted and I'm excited that like now we get a break. And literally within 2 weeks, I'm like, okay, when's it going to be spring again? And I'm already starting to think of, what is that going to mean? And this, of course, isn't just our own experience. This is happening for people all over, beekeepers all over the world. And so I kind of want to share here and take us a little bit back in time. But when we think about all this sort of information, right, that all these people, all these multiple existences, the multiverse, as it's referred to, all happening at once, there's a certain sort of mystique to trying to understand, well, how does that all work? Is it chaos? Is it entropy? Like, what is it? But somehow our bees have been able to make sense of it. And also we as their stewards, I think, are needing to learn how to make more sense of it. And that's an evolving journey, right? Depending on, what your own particular circumstances are, but we all are in this to learn. And we notice that these journeys change, but they still continue over time. So I'm going to take us back in time till the clock's going backwards a little bit. And there's some really cool research that came out. This one actually came out in 2013 in the Journal of Biogeography. And what's really interesting about it is it's showing sort of this historical map here of when bees made an appearance in different places. And so what I would like you to sort of focus on here, and I think I have this little turquoise dot you could see, is really cool, is that for the present, it has a reintroduction of Apis to North America. And you may go, well, what's the reintroduction? I mean, we didn't have bees before, or did we? And some people may be familiar with this. I've got really excited once I heard of this research, but I'll talk about it in a minute. But there is evidence that we did used to have our own honeybee species here on North America, Apis nearctica, and I'll talk about it in a bit. But this is pretty cool because it's showing, where these different bees have been, and sort of what's, these arrows kind of show where they think movement happened, or where these sort of things, merged. And so this is actually pretty cool because it's talking about this this actual migration theories. And I'm sorry, I didn't realize the top picture blocked out some of the pictures, but basically it's talking about, what are these theories? And there's not really a solid decision. Did they come from the Middle East, or did they come from Africa? Did they go one direction versus another? And which time did they go? I mean, it's still kind of up for discussion, but we do know that bees have adapted. And this ties in really well to Dr. Peck's discussion about ecotypes. And so there's over 30 recognized subspecies, and probably even more, and there's more that we can discover, but it depends on where they are, and again, what the management practices are around them. And I'll talk a little bit more too about, what does it mean for us here in the States, where we have been moving bees willy-nilly across this country since they first got reintroduced. And so it's really a different, distinct scenario than in some of these other parts of the world, where bees have really been allowed to have their local adaptation over millennia, right? They have also adapted, and they've hybridized, and they've merged. And that's the reason why all of these bees can intermate, is because they are all at their core the same species, right? They're all Apis mellifera. But then you have Apis mellifera intermissa, Apis mellifera iberica, Apis mellifera ligustica, which, that's what we refer to as Italian bees, Apis mellifera caucasica, right? Caucasian bees, etc. And so there's some real, I want to say, opportunity for us to learn more about what does it mean to have an ecotype, how can it be maintained, or what sort of information and education can we really glean from learning about not only what ecotypes are, but how to actually help to develop them. And I'll talk about why that might be interesting for some of us. So here's a slide about the Apis nearctica that I just mentioned. You can find this online. Engel did this paper. He's also the one that did the historical one, looking at different eras and eons of when bees were present. And so this is what's pretty interesting, is that they found this fossil, right, that's dated 14 million years old in Nevada. And so at some point in time, there was a native North American honeybee. Now, it's not the exact same species as our, what I call contemporary honeybees today, which of course, same as Dr. Peck mentioned, they're a product of the melting pot, right? Just like our peoples are. But they did exist here, and there were other bee species here. So it does go to show that, bees of varying species could coexist. And I share this because there are sometimes folks who think, they either have to be in the honeybee camp or the quote unquote native bee camp, which some people don't realize. Some of these quote unquote native bees were also introduced and have acclimated, some of these solitary or wild, what we call wild bees. And so there's an interesting parallel. I like to draw this because it's, when you look at other countries where honeybees are considered endemic to, they have learned how to coexist with other bee species as well. And the main difference in how that has played out over time, it really rests in our own stewardship, in how humans have decided to a certain degree, overexploit one particular species. So I consider our contemporary honeybees to be sort of these poster children, these exploited poster children of pollinators. And that's not necessarily a bad thing, because they definitely serve as I sort of phrase it as a gateway insect, so that folks can learn more about different kinds of pollinator species. But it does also, my hope is that it will really encourage people to start thinking about, okay, what does it mean to really just only focus on one type of species, or to have that be the one that we're moving willy-nilly and really playing around with. And as Dr. Peck mentioned, when we start feeding them, when we start moving them, when we start manipulating the environment they're in, it really does change then what not only they're learning, right, but how we're learning. And then what does that yield us in the end? And these are not questions that have a specific answer in any one moment in time, or I should say a blanket answer, because that answer changes at every one moment in time. But I like to sort of explain, if we think of the environment as the stage, right? And we think of genetics as the script, then that interplay between the two is really what is the performance, right? We get to see this behavior now on the stage and really get to see how bees are reacting in different climates and with different forage. And that ability for them to be able to adapt, right, to modify, to acclimate, to evolve, to adjust, all of these things here is really quite fascinating. And this is something that, all organisms have to a certain degree, but some have it much more than others. And honeybees have really shown as generalist pollinators that they are very adaptive. That's why we have so many different ecotypes. And this is, of course, not just happening in any one place, right? It's happening all around the world. And all of these different experiences are having an effect on how genes are expressed. And this is really at the core of what epigenetics is. And really seeing to a certain degree how that can be different from day to day and from season to season. Someone's raising their hand, but I don't know if I need to check that or not.
I'll take care of
Thank
those guys.
you. Okay. This adaptation is really what leads to evolution. And what's kind of cool about this, I'm going to play this again because for the longest time I thought these were little seeds, but they're people from an aerial view. And so, yeah, it's kind of cool to, think about not only are these organisms, of course, around us, we have a tendency to look at them more objectively, but we're also a part of this bigger process, right? We're adapting as well. We are plastic as well. And so there's a lot that can be said for these common or parallel experiences that organisms have across the board, even though we're distinct, right? And I don't want to anthropomorphize too much, but I think there's a lot to be said about organic organisms, like that we are to a certain degree all related. And I think that really can help us to better understand if we could imagine what it would be for us in particular to be you know, changing over time, but also our bees changing over time, and to imagine what it would be like if we were them. So this behavior, right, is, and I like this because it's another talk I do, but I'm not going to dwell on it too much here. But it is about these varying interactions, I call it, between broadcast and reception. So these frequencies are going out, right? The perfumes from the flowers, they're emitting a frequency. The buzzing's emitting a frequency. The air around us is emitting everything is emitting a frequency. And so there's a lot of stuff happening that we just actually aren't, with our bare naked eyes cognizant of, but we're experiencing it and feeling it. Let's see if I can go for it here. Here we go. And so, yeah, this type of broadcast and reception, right, is constant, but it does give rise to what we call a phenotypic response. So now we get these more specific sort of behaviors or strains of bees that we see. And this is where we get our subspecies and our ecotypes. And these varying responses, right, are basically creating or coming from created memories, but are also creating new memories. And these memories are stories, and they get passed on. They get passed on, they get encoded, they get contained, they get basically, put in a particular existence that they're able to be passed on, and seeing how that goes. And I will mention this, Dr. Peck had shared the one quote, I forgot who it was from, where it was like, you can breed from local bees, but can you breed a local bee? And that's actually a lot of food for thought right there, because to a certain extent, anytime you have a seed, right, it's going to have memories of wherever it came from. And so if we look at bees or a colony, a superorganism that has all these memories, and it's mainly the queens, right, and the drones who are going to be the ones to pass on those, scripted memories of the genes. What then happens each season? It's constantly changing, right? Because there's new memories. So to a certain degree, I really agree with that. Like, you can't necessarily be breeding local bees, but you can breed from local bees. And it is almost like a chicken or the egg type of scenario, not like the chicken or chicken salad. Um, the other thing too is that these seeds, right, are carrying these traits. And this is sort of just to drive the point home that this is all happening and it's all being transmitted and occurring year after year, generation after generation. And these traits are being cast out, especially when you are focusing or relying on open mating, right? It becomes a mixture, right? You're not necessarily in control of which drones your bees are mating from unless you're doing a closed breeding population somewhere. But this is constant. So just to sort of review for folks who may not be familiar, and this is what the books sort of say at this point. This is information I borrowed from Dr. Shepard, who was my master's advisor at Washington State University. And so bees were brought in, they have records from the 1600s, but it actually does even go a little bit before that for when the Spanish came in. And so these different species, or sorry, subspecies of bees were brought in. It was a very hard, arduous trip, right? It wasn't easy. A lot of folks, landed on the eastern shores first, but then over time started to spread westward. And those bees adapted as people moved westward as well. You'll see there's a pretty big significant gap between 1891 and 1990 on the bottom left chart. And that one actually is because they shut the borders in 1920 to what they call the Isle of Wight disease or tracheal mites. And so that law is still on the books today. Like we cannot just bring bees from overseas. And that's why you'll hear of germplasm importation programs where they can bring in the semen, which also has to get screened for viruses and all these things. And they have to do instrumental insemination and they can cross back it multiple times to get to about 97% of the original stock line. But it's not as easy as just bringing bees over as it used to be. The other reason for some of the gaps here too, and not super significant, but when steamships became invented, then it became easier for them to start bringing bees in from farther away. And so that really started this whole melting pot extravaganza that we have here across the country. Bottom right is just actually showing a little bit of some of the importation that came out of Washington State University. And actually, I'm sorry. Yeah, the Palmanella, I think they're now trying to get out. It hasn't been really made publicly or made available publicly because they have very little of it. And also too, it's a same thing. It's like you have these beekeepers traveling halfway around the world to collect this very fragile sort of germplasm, semen, and bring it back. And it's pretty arduous as well for them to do that. Not only that, but the cryopreservation process is still something that's being further developed. And so while it does provide a tool, it's not necessarily, going to take over as everybody's going to start doing this because, there's one aspect of just learning regular beekeeping. There's another aspect of learning breeding. And then if you want to start doing II and cryopreservation, those are additional skills that are, can take years to develop. So we're going to go back forward in time now and sort of bring you back to present day. And share a little bit, like as we've traveled through time through this little wormhole here. I'm doing all this, like hopefully keeping you folks awake because I know you've had a lot of amazing talks today. So I rely a lot on my visuals to sort of snap people awake. But we go where life takes us, right? And so it's the same for our bees. They're going to go where they're moved to or where they can actually fly to. And that is going to perpetuate this plasticity and this ability for them to continue learning and to gain experience and to then turn those into memories. And so this is part of that echo starting here with Dr. Peck, where there's a lot of different papers out there, a lot of really cool ones. And I'll share the link to this slideshow because I did it via Canva. So I have an online link. So anybody who wants to go back and look at these, you can really sort of delve in more. And the one that I really like a lot is the one that he actually referenced, which is this COLOS. And actually that stands for Colony Losses, which is basically an international group of scientists who volunteer their time to work together on interesting research projects and also different working groups. this paper, which she already referenced, I won't dwell on it too much, but there were some questions about the experimental design of it. But it's still quite interesting, I think, in that basically what it comes out to is, for the results of this particular experiment, they found that a bee that performs well in one region may not perform well in another. And this kind of ties into that question is, well, yeah, were they reared the same? Did they have the same nutrition? I mean, there's a lot of sort of more unknowns and questions that we have to start thinking about before we can take anything at face value. But I have to say that that aspect of research is what really encouraged me to go back to school at 45 years old, was because I was having these observations that I wanted to better understand, and I wanted to be able to seek and really sort of guide research that could help not only me to better understand, but that could really actually help to quantify beekeepers' observations, because the scientists have their sort of perspective and their approach. And then you have these very practical, hands-on professionals who know how to keep their bees going, or who are constantly learning, and they're also constantly adapting, right? Their management. But yet, because their experiences aren't peer-reviewed, we kind of dismiss them. And I find that to be quite unfair. So I really became inspired by part of this research to actually go back and learn more, so that I could actually look at some of these different ideas, and then also to help better advocate for farmers. So what they found, of course, is local bees fare better than non-local. This is what their results sort of claimed. And mainly that it indicated that a more sustainable beekeeping is possible by breeding bees from local populations, right? And this again kind of ties into Dr. Peck's, you can breed from local bees, right? And so what does that mean for us here stateside, especially with a country that's huge and diverse as it is? And given the fact that we have moved our bees willy-nilly from all sorts of different climates, adaptation, and I didn't mention this, but, it doesn't happen overnight. And so it takes a really long time for not only conditions that are somewhat stable to be sort of impressed upon any particular organism, but also for that to then be able to adapt to varying conditions. And it's all happening at the same time. Again, it's this micro macro thing again, which can feel slightly overwhelming, but at least we only have to stay conscious of putting one foot in front of the other, right? And so same for our bees. They really only have to stay conscious of basically making it through the season in which they're living in. But knowing how diverse our country is, the different grow zones, increasing drought or wildfire or flooding, or, all of that stuff, hurricanes. We ourselves here in northern New Mexico, we had the worst fire in our state history year before last. It was the Calf Canyon Hermit's Peak fire. It burned for 81 days. It was 51 miles long. Took us 2 weeks to move all of our bees out. And we pretty much had very little production that year. We got saved by finally late rains that came, which then of course washed all the ash and, whatever seed stores didn't get burnt up away. So now there's a lot of reforestation efforts near us. But yeah, we got saved by these late rains that then gave us a little bit of honey flow. So every year is a different experience. It really, brought some more awareness to us as to, okay, what's the weather going to be like, right? How are we going to start to strategize? And I want to share this bottom left map here, actually, which is really interesting because it's talking about how different species are going to be able to adapt if temperatures increase. And you can see on the right, and Michigan's included in this, that there's very little survival of different organisms, plants, animals, being able to adapt rapidly. Whereas in the West, there's a little bit of potential because it's already getting hotter. That's their living existence, right? So this is something for us to be mindful of, is if, we have these extreme weather scenarios, how is that going to impact the biodiversity overall where we're at? And of course, this is a model, this is a projection, but this is something that, we should really be aware of. So in a sense, I call this my Queen for All Seasons sort of sub chapter here, which does start on a site specific level, from place-based, but then also how does it become more adaptive? If the choices we make are actually going to affect how our bees behave, right? So if we start moving them, whether it's willy-nilly or even within a pattern, that is impressing upon them. And so I'd like to take the idea of site-specific bee breeding or selection one step further to looking at it more through a trans-regional lens. And I'll kind of give some examples of that here. And that is really something that has come about from my own adaptation of one starting in one place and then being able to work in different places, learn from different beekeepers and with different kinds of bees to basically come to the conclusion that I know nothing and life is about change. And so that's about the only thing you can count on. And that there's just, it's constantly learning, right? So I've learned not to get stuck on any one particular philosophy or even regiment, because I see that depending on the conditions, what you choose to do or not do with your bees really has to remain flexible, right? That's the only way you're going to be able to survive. So I'm going to focus in now on Zia queen bees, which is my home farm. As I mentioned, it's celebrating 20 years. It's funny because I say that with, I mean, I'm happy about it, of course. I also feel like it's a miracle. And I'm also really exhausted just thinking about, oh my God, it's been 20 years. Yeah, I'm so tired. But it is really thrilling. And it is something that I'm humbly proud of, but I also recognize that at any moment, you know, that may not be the case because it's been a real labor of love and it's had its ups and downs. And I think for those who, you know, and as was mentioned by folks before too, you know, it's one thing to sort of, and I don't mean this in a negative way, but to kind of play with bees and to be able to um to have them as sort of a side project. It's very different when you're trying to make a living from them and actually also really trying to sell them commercially, right? Or to be able to interact with the public on a supply level. There's a lot more lessons that come in with that. And again, you're dealing with shifting climate. So I like to show this picture because this is actually true to us. Our farm was up here for 11 years. We're now 10 miles down the road. And there's another mountain, which you can't really see on the sort of right around the corner from this, which is called La Jicarita Peak. And that's where our farm is now. So we're still on what's called the high road to Taos. And it's still at over 8,000 foot elevation. And people see this and they don't realize like, wow, that's in New Mexico. And it's like, yeah, it is. So the southern part of the New Mexico actually looks a lot like what you would imagine the dusty sort of southwestern, you know, tumbleweeds blowing, that type of stuff, spiny plants, cacti. And then as you get into central New Mexico, you actually, you know, you'll follow up the Rio Grande. That's our main water vein. And you'll follow up that and you'll start to actually get into wetlands and some bigger sort of valleys, riparian valleys. And then you really start getting into high desert, and then you're in actually the Rocky Mountains. So we have 6 out of 7 life zones here in New Mexico and microclimates galore. I mean, literally you drop with elevation within 30 minutes, you can drop 3,000 feet and it's a totally different experience down there, totally different timing of bloom. For us, and especially because Mark, who, you know, got started in Michigan, we started as migratory beekeepers in that sense. When we started working together, we met in Florida and so worked there for off and on for a few years. We started, you know, we moved bees from Michigan to Florida, then Florida to New Mexico, then we did Michigan, New Mexico. And then we had kids, and then it's like you don't have time to be driving all the time. So so that definitely also shaped our management and what we ended up being able to select for with our bees. But our main focus has always been on longevity, which is an umbrella trait. And that's why I have this umbrella here. And so when we say, you know, that one question that got answered in the chat, which I thought was really a good question, was, you know, what about epigenetic selection for Varroa resistance, and is that possible? I do think it is possible, but I think it falls under this larger umbrella trait of longevity, because if you can select bees over time and those that can make it through more time, then the ones that are not pest and disease resistant they're not going to make it, right? So they fall out of the selection pool. If they can't, you know, stay healthy, they're going to fall out. If they're grumpy or, you know, spicy, we get rid of them, which in New Mexico, we actually haven't, gosh, I think maybe the last time I had to pinch a queen for aggressiveness was when we were doing some breeding downstate before it got too windy and too dry. And that was 18 years ago. It's the last time I pinched a queen. And so it really just depends, on where you're at and what you're doing. But we borrowed a term from the cattle industry that's actually called the overall lifetime merit, so OLM, and that's what we select for, is seeing how our bees can make it through time, and then actually breeding off of the ones that last the longest. And these aren't only ones that are staying in northern New Mexico where we're based, but these are ones that we're actually testing out in different regions as well. So that's me trying to take it a step further from site specific to becoming more of a regional or trans-regional selection. This is just sort of a little quip on what that selection or sort of how that evaluation happens, right? You start to develop your own pedigree, or the traits that you're really wanting to monitor. For us, like I mentioned, it's longevity, because I feel like it includes a lot of other things. But we don't just go off of time. We're also looking at, temperament, as I mentioned, pest disease resistance. Are they able to make enough honey? Can they overwinter successfully? All of that really falls under that umbrella. So we're looking at multiple traits. We're evaluating them in terms of what we like, what we don't like, and then also keeping track of those. And so we actually use colored plaques. The colored plaques referred to the International Color Code of the Year. And this is helpful because then if we pull into the bee yard, which I'll show in another slide here, where it's snowy or what have you, we can, you don't necessarily have to get out and look at each hive. You can just see that colored plaque and we know how old that queen is that's in there. And then you repeat that. You do that every year. And so for us, we're breeding for, this longevity umbrella trait, but that also allows for this inclusive sort of experience for the bees to adapt, for them to acclimate, for them to survive, and ultimately that longevity. The picture on the left here is of a few different, or maybe it's your right, sorry. The different mating nuke styles. We used to actually run queen castles. So these were standard deep, or what we call 3/4 boxes, and dividers in them, usually one divider, then we'd have, a 5x5 frame split next to each other, or two dividers, and have 3 mating nukes within one box. And the middle one would have their entrance out the opposite way, and that way the two on the ends, their entrances were farther from each other. This was, how we ran everything, and it was great because we could use the same equipment. We just had to pull the dividers, harvest queens, leave one, pull the dividers, and it becomes one single. You could even put an excluder on top and put supers and have mating nukes actually making honey as well, so they wouldn't get plugged up, or anything that got full with honey, we could pull it up to the top box, but we had an excluder so the queens couldn't cross over. We also put a sheet of landscape cloth, or just window screen, over those dividers so that queens can't cross over. Sometimes they still do, but it prevents it. But the cool thing about that screen, and it's all about being a smaller operation where you really kind of have to diversify within what you do, is those screens can then be pulled out at the end of the year and allowed to chill, whether it's outside because we get cold enough, or you could put them in the freezer, and then you can twist them and all these little propolis flakes fall off, and it's a lot easier to harvest that way than big old chunks that you're scraping. And Mark makes capsules with it, makes tincture with it, dissolves a lot easier, and even sells it raw. So it's nice in that it sort of creates a nice sterile little pouch for these new queens to mate when those screens are on. So there's continuous needs, right? Whether you're migratory, or whether I sort of describe it as sedentary, meaning only that you're not moving bees from place to place. You're going to have different needs or considerations. Whether you're a commercial professional, right, and your livelihood's depending on it, or you've got employees that you got to keep, with paychecks, or if you're a hobbyist / novice. And I don't really like to use the word hobbyist because the only type of hobby animal I've ever heard of is a hobby horse, and that's not even real. And novice doesn't necessarily, I mean, there's plenty of hobbyists who are have a lot of experience. So, these words are problematic. But I use them just to kind of show there's sort of these kind of opposite ends of the spectrum, but there's everything in between. I consider us to be small scale commercial. We don't run thousands of colonies, but what we do run, we run in a way that we're trying to supply people, share bees, and make some income with it. And so we run anywhere between, the numbers fluctuate, but it can be anywhere from between, 100, 150 to 300. I think at the most we ever had one time was, I think, 450. And that's, full size, but then during the mating season, we can run anywhere from, 100 mating nukes up to, several hundred, depending on the season. And that's changed over time. We've had, like I mentioned, it's been sort of up and down. We've had, of course, extreme fires, we've had bears, we've had, all sorts of fun stuff happen, but that's what's required and sort of inspired us to be more adaptive in our management. And about 10 years ago was when we started going out to California, just with our breeding stock, to actually do breeding exchanges, to also find mentors of other queen producers, and then to also just get a little jump on the season. And it wasn't until about a few years into that then on occasion we'll do a little bit of almond pollination, and that's usually just if one of our collaborators is running short, but it's not our main point of going. And then there's years where we don't go, like this is the first year in 10 years that Mark has decided not to go, and for numerous reasons, but one of them was just, the past 3 like springs there in Northern California have been super wet and quite miserable, and mating has not been as good as it could have been. So it's like, why bother going? But I think this year they're having a better year. And we've got a lot of other stuff that we're working on too. So, it's kind of neat to be able to shift gears. And I'll show some pictures of this cold storage that he's built up at the farm, which is one of the newer practices that he's trying out. These types of different needs and considerations really depend, of course, on whether it's nature versus nurture, but I like to call it nature nurtures and tortures. And to me, that's mainly because, there's what won't kill you will make you stronger, right? And so both are involved, but also how we manage our hives. And Cory actually mentioned this, which I thought was great. He talked about IPMs, and I think that was a great talk this morning, integrated pest management, whether that's, biocontrols or you're using cultural, right? Or you're using chemical, there's all these different ways, but all of these things are playing into what we then end up selecting, right? And so when we look at the different environments, the different times a year, the different climate, the different forage that's available in these different times a year. That picture of Mark holding that little baby, that's our now 15-year-old who's 2 inches taller than me. So time does go fast. This is where we're at in northern New Mexico. We do get some good snows sometimes, and we always leave upper entry ports. That's part of our main one. But it'll snow and then it'll melt and then we'll get more snow. Sometimes they can get nice and insulated in there. And this is part of our overwinter selection process. And so all of these different things sort of come into play when you're looking at, now you want to breed bees or rear queens. And so I kind of see it as, you've got to have good quality genetics, you've got to have mindful management, and you have to have conscientious propagation or quality rearing, right? And how you're actually supporting that whole natural process of reproduction for the bees. So these are just a couple sort of shots just to show folks how we do it. I won't dwell too much on it because you saw a lot of really cool talks today about different cell raisers, and there's so many different ways. It's kind of fun to try a bunch of different kinds, but really find what works for you, obviously. We do the Doolittle method of grafting. We put them into sometimes queen right cell builders. That's what Ange kind of described as the honey pillow, which I'm like, I've never described it as that. I'm going to keep that. I usually just call it like a sandwich super, but I like the honey pillow. And then sometimes now we actually do queenless cell builders, but Mark's new big thing is let them swarm. So he lets them sort of rear their own cells as well. So we employ a lot of different methods. Sometimes we do walk-away splits. Sometimes we'll do grafts. It really just depends on, what sort of our goals are for the season, but also what commitments we've made or what interest we have at different times of the year. So this is actually, I'll share a QR code for a free manual that you can download. It's also from SARE, or Western SARE in this case, Sustainable Ag Research Education. It's pretty dated, so I'm going to be making a new one in honor of our 20-year anniversary, but I came up with that one in 2012. And it just shows our, this is a queen rank system. So we usually have the queen on the bottom, laying queen on the bottom, and then an excluder, and then we have supers, which basically are filled with honey or in the process of being filled with honey, then another excluder, and then the actual cell raising box on top, which does not have a queen, but is filled with nurse bees because we're able to pull brood up from the bottom that's going to emerge, and even some older open brood, which then, the brood pheromones up there, so nurse bees come up, but they can't smell their queen way down below. And so they're really encouraged to start feeding them full of royal jelly, which is what we like to see. And each one of these cocoons is like a seed, right? It's got these memories, these experiences that are going to get passed on and then put out into all these mating nukes that are then going to go out and further that whole process. If you guys can't tell, I like poetry. So, um, and of course we can't forget the mighty drones, right? They really are. I don't think they get enough attention, and I'm really excited to see some of the newer research coming out, and really what more we can learn about drones. But in essence, they are replicas, at least, of the genetic information from their moms. And so if you really have a queen you like, that's, rearing daughters off of her is only going to give you 50% of her information. But her drones are 100% her information, and they're going to go out and be the ones to really pass those memories on. So they are a very major part of that equation that shouldn't be overlooked. So why is selection important? And I'll just kind of breeze through a few slides here. I won't dwell on it too much because I think I'm probably going to hit time here. But I'll talk about some of these, what I call case studies. And one in particular, first we did a project in 2007. That was our first SARE grant. It really helped to get our breeding program launched. And that was just working with beekeepers here in New Mexico. And then we did one in 2011 through 2014 that was called the Rocky Mountain Survivor Queen Bee Cooperative. It got funded by SARE for, I think, 2012 through 2013. And that included 9 beekeepers. And this was actually 6 of them in northern New Mexico at different elevations. And then also 3 in Colorado at different elevations. And so it spanned basically close to 500 miles, and between 5,000 and 9,000 foot elevation. This is that QR code for this manual, which actually gives a step-by-step breakdown of the rearing process, at least how we practice it through Zia Queen bees, and then also how some of our collaborators in this project. And I learned a lot from this project. I learned some things that were quite bittersweet, which is it's a lot easier to work with bees than it is with people. But I also learned that, professionally, like I was fascinated with sort of doing things in community and us figuring out together. But I also learned that there are some people, just human dynamics, where they need a set thing, and that can be hard to do. So I learned a lot in terms of how to do projects and how to actually make them work. And so I'm excited to share with you in a few more slides about my newer project. And it's sort of lessons learned from these experiences that I'm able now to really help guide these projects. And so, yeah, when we're looking at these different kinds of experiences or these different locations, even different hives, different beekeepers, and how that sort of coalesces into this one larger kind of body of knowledge, right, that we can share with each other or that we can pass on. It's really interesting. I think, that it all changes over time. And so I'm not going to dwell too much on this. Hopefully you guys can read somewhat swiftly. But my humble beginnings began in South America and as a Peace Corps volunteer. And it was all wild hives, and we had to carry machetes. We had to make all our own equipment without power tools. We even made our own smokers out of old coffee cans. It was a very interesting sort of introduction to beekeeping because it was very much on the kind of wild and rugged side of things. And with bees that were slightly aggressive for sure. I'd had no other experience, so I didn't know what to think. I had the opportunity shortly after Peace Corps to then also go to Mexico. I learned that you shouldn't over insulate because I worked with a beekeeper there who had so much insulation on their bees, but they were like super hot and they were just, the humidity factor was intense and they were quite aggressive. But it was still really cool, to see now, oh, here's bees in a different place and how are they surviving? What is their sort of MO? I went to Hawaii and worked there for 5 years. And that actually gave me my first introduction to queen rearing, more specifically. And of course, there wasn't on-site selection there for bees, but the owner at that time would bring Sue Colby out to bring semen out there because, again, you can't just take bees out there to do instrumental insemination and then use those as breeders. He was always sending brood in and queens in to get analyzed by other labs to sort of test for different traits so that then he would be able to have stock that he thought would be helpful to his customers all around the world. So I worked at Hawaiian Queen first and then also at Kona Queen. And I learned a lot. I learned a lot actually from working with beekeepers from all over the world, which just really gave me this sort of, oh, you can have a job anywhere if you know how to beekeep. um, and there are a lot of people who sort of go, between the different hemispheres, just working for different beekeepers. But yeah, after doing that for about 8 years, including my stint in Florida, which is where I met Mark from Michigan, I kind of got tired of bending over for other people and thought, well, maybe I'm ready to do my own thing. And Mark had actually already been running his own bees in Michigan, more specifically for honey production and selling straight to the Marquette Food Cooperative. Superior Honey Farms was what it used to be called. I think there's now like a Superior Bee Farms or something like that. But yeah, back in the day, he had Superior Honey Farms. And yeah, it was really cool to be able to start to see now this migratory, because when I was in Hawaii, I didn't get to really see migratory beekeeping. Okay, yeah, from one side of the island to the other, but that's just moving between bee yards. Now this was like actually really sort of transcontinental to a certain degree. In Michigan, I learned a lot about overwintering techniques and multiplying your resources. Mark had really started with, a couple hives and a couple books and a couple friends, and over a few years that, his buddies found something else to do. And he had, 2 hives that went to 5 to 17 units of he didn't know what, and realized that he wanted to go work for a commercial beekeeper, which is when we ended up meeting in Florida. But a lot of his experience there really started our breeding program because he started just breeding off of the bees that were making it through such intense scenarios there in the UP. And then when we teamed up, I don't know how I convinced him to come to New Mexico, but somehow I was able to. And yeah, it's been 20 years now that we've had Zia queen bees. We do an open population. I put closed population to establish the breeding program because to a certain degree, when we're up in the mountains, we're the only ones with bees up there. There's a few more people now who have cropped up with bees. Some of them get their bees from us. I always advocate to communicate with folks to be really mindful if they're going to bring bees in, like to really do their research as to where they're bringing them in from, because it really could just take somebody bringing in something that could shatter our whole breeding program of selection for 20 years. And so we kind of creep farther and farther up the mountain, hence moving even 10 miles down around the road to get a little bit more isolation. So being able to use that. But we actually, we do open mating. I do know instrumental insemination, and I am going to start doing that a little bit more just in terms of cryopreservation and more targeted crossings, just because then it helps to speed up time between different places and sort of trying things and with other beekeepers. But our stock changes every year because we're selecting for this longevity, right? And so that can change every year. But what's really cool is that some of our bees that are, of course, neighboring beekeepers by who are close enough, if they have any of our bees that then have passed the 2-year mark, then we actually ask if we can graft those back into our population. So we try to also bring back in what also was a part of the breeding stock several years before. And as I mentioned, now we do, New Mexico, California, although this year we put a little pause on that. But it's really allowed us, how to share resources with other beekeepers and really starting to see our bees in also different places. So seeing them in Michigan, seeing them in Florida, seeing them in New Mexico, now California, for us, we need a good all around bee, but we also recognize that, that's not the case for everybody, nor will it work for everybody, right? But my experience at Washington State when I was doing my master's really then sort of brought me up to speed with breeding research and also the process of scientific inquiry. I learned how to do II there, and how it can be a good tool. And then also looking at how these larger institutions really sort of support and provide infrastructure for breeding programs. When you have that type of access to an infrastructure such as a large university system, it can allow you to do some things that you wouldn't necessarily be able to do on your own. But it can also be a little bit limiting, right? Because it depends on funding. It also depends on the university's interests or who the funder is and what their interests are. So, sometimes you think the grass is greener on the other side, but I like to be able to walk between both worlds, because I think that it's the marriage between the two that really can kind of help us figure out how to have more sustainable beekeeping. I put in Idaho, but I did cold storage there 1 year just to try it out, because I was going, between New Mexico and Washington. And it was really interesting. And the topography of Idaho actually reminds me a lot of New Mexico, because there's really cool terrain there as well. But it just really, all these experiences for me, just as I mentioned, make me realize that I know nothing and that I'm constantly learning. And there's more to learn. So I'm going to try and speed it up here, because I think I am running out of time, and I apologize for that, but I'll answer questions via the chat. So this Queen for All Seasons, as I mentioned, and I now look at it, as this trans-regional sort of survivor stock and longevity-based breeding program. And we on occasion, Mark will use oxalic acid. I still don't use it, but he does with some of the stock. Sometimes we do garlic and powdered sugar. I mean, sometimes we do these, what I call supplements, but we aren't on a really hardcore chemical treadmill, because again, what you're doing is going to impact what you select. So just wanted to give a big shout out to Mark, who's in the other room, that we're, celebrating 20 years here. He works really, really hard. He's 10 years my senior, so he's just a badass in terms of his endurance for keeping up with all of this. And he continues to learn, and I really want to give him credit, because I'm sort of the talking head of our farm, but he really is the wizard doing all of the magic behind the scenes. And so I really appreciate that. And our main collaborator is Aiden Wing. He's with Wings and Nature Bees. This is in the Santa Cruz coastal mountains. So this is where we go to try and get that jump on the season, where we can get eucalyptus and rosemary. Almonds are 2 hours away, but on occasion we'll, let him borrow a few to take them down there. And we do a whole, season sort of expansion, making splits, getting newts ready, rearing queens, and getting to hang out with other producers as well, which also keeps us really not only humble, but there's always something more to learn. Yeah, just some shots from the field, both in New Mexico and in California, raising queens. Now that we're getting a little bit more mature in years, we've also started switching over. I mentioned those queen castles, those with dividers. Now we've switched a lot over to what we call our wooden chubs, or even some styrofoam mating nukes, because they're just a lot lighter on your back. After 20 plus years of beekeeping, the schlepping of heavy boxes takes its toll. These are pictures actually just from this week, and I wanted to share with you. So the top, this one over here where I have the little turquoise dot, is this modified closet that Mark put inside the garage, and that's actually where you can put some mating nukes to overwinter, or some singles even. And then he pulled them out actually just last week, because he knew that, they're going to be running out of food stores, and normally he'd be taking them to California, but since he's not, he took them down 3,000 feet to 5,000 or 5,500 foot elevation, and then was able to actually put a little bit of liquid feed on them, but that'll get slurped down quick. Daytime temps will get up nice, but the nighttime still drops down. We're still like in the 20s at night. And so you don't want to put too much feed on them, but he gave him just a little bit. And he also passes out a lot of crystallized honey that he saves. So there's a lot of different ways to sort of help them along. And those are just the ones that are smaller. But this leads me to, this more collaborative effort, and I'm getting to the end here. We got a Research to Grassroots grant, and this is actually for ABBA, or Adaptive Breed Breeders Alliance. Right now, the grant is focused on 12 producers. We've got 2 in Oregon, 2 in California, of course, 2 in New Mexico, 1 who does North Dakota, Texas. You saw Ange this morning, Massachusetts, Florida, but they're moving over to North Carolina, and then also New York, Florida, and Vermont, Florida. And so we've got producers from all over, and really it's an opportunity for us to learn from each other, but to also share techniques. And our funding is for 3 years, but the hope and actually the plan is that we're going to be able to continue this and expand it out. And I really want it to be open for everybody. One of the main sort of inspirations for it came from I got the opportunity to attend Honorseo, which is the French Queen Breeders National Association. And it just blew my mind as to how many different beekeepers come together. They don't care if you have one hive or if you have 1,000. If you're interested in good quality genetics, you're welcome to be a part of the group. And that's my plan and hope for ABBA. So stay tuned because we'll be opening this up to include more beekeepers. We just wanted to get some data initially and be able to share an anthology and get some, cryopreservation and some genomics done. So we have a starting point from which then to help other people who want to learn more about their bees. And it's a coast-to-coast network, so it includes those 12 breeders, but it also includes 12 researchers as well from across the country. And so it's been really exciting to kind of see what those conversations are because everybody has their own interests. And so part of this network is really just allowing for those, it's kind of a think tank for these conversations to happen where folks can start to explore ideas that they want to do research on together. So yeah, I'll end it here. As stewards of our lands, air, waters, and health, it's really imperative for us to be proactive. These are my kiddos. Of course, the first shot is when they were little, and now, as I mentioned, my daughter's 2 inches taller than me. So they put up with the bees, and it really does allow us to all work together to make these castles, right? To have these queens and their hives living in their own queendoms and being able to share them with each other. So thank you. I will end it there. And I don't know if I have time for questions. I think I might have gone a little bit over. I'm really sorry, but I can answer questions in the chat.
Oh, that's all right. Thank you so much, Melanie. You did a wonderful job. We appreciate your time today. There are a handful of questions. We are going into a break, but it is
Okay.
it's just a bio break. So if anybody has to use the restroom or get a snack, feel free. Our next speaker is Dr. Karia Wagoner. She will be speaking at 4:30. So we got a few minutes to answer questions if you want to stick
Oh,
around and
good.
listen.
Yeah.
Yeah.
Oh, good. I'm glad I didn't want to cut into anybody's time. Nonetheless, Kara's time. I'll do
Yeah,
stop
or
share.
else, right?
I know, right? Okay. I'll do stop share.
All right.
Okay.
So do you want to just grab the questions from the panel, or what you want me to tee them up
Oh,
for
why
you?
don't you go through them for me?
All right, sounds good. So this one's from Tiffany, and Tiffany is in Texas, I believe. If breeding for adaptation, acclimation, survivability, and longevity, what are some markers of each type to begin studying? And so how do we know if our queens are adaptable? She says she has some solely feral bees in her colonies and a small backyard beekeeper in Texas, starting in her 4th year, taught by Les Crowder. And thank you for the talk.
Great. Well, I'm a big fan of Les. He's a buddy. He's from New Mexico originally. He's a big top bar beekeeper. Yeah, what are some markers or what have you? I think we're really getting to a quite exciting time in bee science and also in field applied research because now there's tools. And coming up, you guys are going to hear from Karia, who's going to talk about the UBO test, and that's a great new emerging technology that's coming out that's going to allow us to then to really start to explore more what these markers are. So one of the things that ABBA is doing is we're doing genomic testing with the help of Dr. Garrett Slater and also Dr. Adrian Avalos, who I realize now I need to add to my slide, but they're actually based out of the USDA ARS Baton Rouge Bee Lab. And so they're going to be doing some low frequency testing on some of our, or sequencing as they call it, to get some initial information, but then we're hoping that whatever that data yields, meaning these producers are going to send in some drones, they're going to be analyzed, we're going to see what the stock is, because a lot of us, again, are running mutts. What do we have? See what we have, and then from there, see what does that information yield? Are there some things that we're seeing? And especially too, as these producers have been monitoring them, maybe now we can actually really start to look and sort of deep dive in and see, okay, can we have some marker assisted selection? So that's coming up. That's happening, I want to say fast and furiously, but probably not as fast as we all think it will, just because science takes time, right? And a lot of these emerging technologies, have some good field practice. But I'm really excited for these. I hope that kind of answered your question. But stay tuned. Oh,
How
I
do you
can't hear you,
adjust?
James.
I'm unmuted now, I think, right? Yeah.
Yeah.
How do you address drone quality with your open mated queens? Drone saturation technique? Would love to hear.
Yeah, so for us, we put extra drone comb in all of our breeder colonies. And it should be noted too, I mean, your bees are only going to pull out as many drones as they can actually like nurture, So, I've found that when I put an extra frame in there, if they fill it, that's great. If not, it's not a big deal. Then they'll usually plug it with honey, right? But we will actually take those frames sometimes and actually move them to different mating yards. I didn't really show an aerial view. Maybe I'll include that in my presentation in the future, but so where we are on the high road, there's little villages about every 5 miles from each other, or maybe 2.5 to 5 miles. And so one of the research things we want to look at is how far are these drones flying, but we can move our drones, or at least these frames, and support colonies in between these different little valleys up in the mountains. And so yeah, we basically try and have drone comb in every single colony so that we know we have enough saturation. And as I mentioned, we're small scale commercial. So, we have more than your average backyard beekeeper, but we're not talking thousands of hives here by any means. But we'll have, our support yards and then mating nukes, or sometimes in the same yard, but separated a little bit, or just right around the corner.
Fantastic. You did a great job. It looks like you got a lot of positive comments about the storytelling motif you had with your animations. That was very
Oh, good.
helpful. And I do want to comment that it was nice to have as a bit of a break from the more hardcore aspects of the topics of the day. So it was a perfect fit, and you did a great job. I will let you tackle some of the other questions offline, and I'm going to move on to a presentation and slide over to Kara here.
Yeah, I would just
Sorry, accidentally hit the button too fast.
No, it's all good. I was just going to say, stay tuned. We're going to have information coming out from our objectives from this ABBA grant. So there will be more graphs coming.
More graphs, yay. Will
Hi,
they be
Karia.
animated graphs?
Yeah. Thank you. See you.
All right, see you in a bit.